Recorded up. So I'm starting the recording for today's session. So over here I've shared you different softwares. One is the folder called VMs. So once you go to this VM folders, there are a few OVA files and one exe file. When you install this exe file, that is the Oracle VirtualBox, it will look like this. Although all the steps are documented in the installation of sandbox.docx, but if you want to write down, you can write down. You have to install the exe file called VirtualBox, Oracle VirtualBox, and it will look like this. Although the VirtualBox is like this on the left hand side will not be visible to you, it is an empty screen which will be visible to you. So once you install this, just double click the exe and you'll be able to install it. There's nothing great in that. Once you install it, click on File, click on Import, and browse the OVA file which you have downloaded from here. So there are two OVA files. You can use a 2.1 OVA file that is lighter and that will not eat much RAM on your PC. But if you have a good configuration laptop like 16 GB or something like that, you can use a 2.2 version. But otherwise, I'll suggest you to use 2.1 OVA. Because 2.2 is pretty heavy and that will require more than 4 GB RAM at least to run up. I run it around 8 GB RAM, then it works fine. Otherwise, I request you to use 2.1, and all you have to do is File, Import Appliance, browse that file, and click Next, and this will be visible over here. Once it's visible over here, right click it, go to Settings, go on System. Here is the memory which you can allocate to this VM. I have allocated around 7.5 GB of RAM. You can allocate the RAM as per your laptop. So if your laptop has 4 GB RAM, you can allocate it 2.5 to 3 around, and rest 1 GB you can leave it for your laptop to breathe. If you have 8 GB RAM, you can give it around 4 GB of RAM. If you have 16 GB, you can give around 7 or 8 GB of RAM. And rest all will remain same. And then you have to just say right click and start. And once you say right click and start, it will start a window like this. It will start a window like this, and there will be a lot of things which you will see. It's starting up. It will take around 2 to 15 minutes based on your laptop configuration to start up. Once it's started up, our Hadoop single node cluster is up and running. Everything installed over there, be it Hive, be it Uzi, be it Pig, everything is there, configured, everything installed. So Puri, just a minute. So everything is installed over here. It's running up. How to connect to it, how to use it, I'll just talk about that part. By the time, if you have any questions, just let me know. I'll read the Puneet question. So Puneet says, when the sandbox is off, then my laptop will have all the, yeah, definitely. When your sandbox is off, if you close it, it will say power off, and if you power it off, all your RAM would be freed up. Anyone else has any other question? How to install it before I tell you how to connect to it and use it? Okay, so I'll assume no questions. Although if you face any errors while installation, any specific errors or anything which you get it, just browse this document. This is everything how to configure the different, how to basically look at or debug the different errors which you are getting up. All the most common errors are there in this document itself. That will talk you how, if you are facing any errors, how to basically debug them. Once you install the VM, you can download this putty.exe and winscp.exe and use them. So putty is nothing but you can do an basically SCP to this machine, and WinSCP is an FTP protocol software to do an FTP protocol to this machine. So we'll be running all of our programs on a single node virtual cluster, but when you'll be connecting to your production cluster, those will be multi-node. You will be connecting the same way, you'll be running the software same way, there will be no difference at all. So once you download Putty, when you click it, when you open it, It will look something like this. Here you have to type an IP address, that is 127. You can write it down please. 127.0.0.1 your localhost. Port will be 4 times 2, not 22. And SSH, and just press enter. It will open the console. On this console, you have to type user as you and password as Hadoop. So I'm pinging you all these details also on the chat window, but you can write it down please. 127.0.0.1 and port is 4 times 2. User is Hadoop and password, sorry, user is you and password is Hadoop. And you are logged into your Hadoop world. Here you can run all those commands which you were running that day. Hadoop fs minus ls. Any confusion, any questions on this part? You can just quickly say yes or no on the chat window. I'm just waiting for a yes or no on the chat window. Okay, Puneet says no. Okay. I'll assume no from others also. So now this is how you will be connecting to your Hadoop cluster and you'll be running your commands from the command prompt. To go to the UI, what you have to do is once your cluster is up and running, you have to go to the browser, type 127.0.0.1 and colon 8000. This is the URL. Press enter. It will ask you for the username and password. Username and password will be printed on the same screen somewhere on the top. A user would be you and the password will be printed over there only. You use that username and password and you can use the file browser button over here to browse the different files in your SDFS file system. Okay. So the third thing which I have shared with you is Maven and Eclipse. So these are technical Java things, but for those who want to try the MapReduce program, please listen to it and bear with it. This will be good if you try it out, although you'll not be using it, but just try it out and that will give you a little bit more confidence. So Eclipse is nothing but is a kind of uh, editor for Java. So normally across the world people use Eclipse only. I would say 70 to 80% across the world people use Eclipse only for editing Java files. So this Eclipse is shared with you over here. You can download this Eclipse 32-bit or 64-bit based on your laptop configuration. And this document talks about how to install Maven plugin for Eclipse. You can read it. It has everything in detail. So once you download this eclipse.exe, inside that there will be one file called eclipse.exe. Just double click it and it will open a window something like this. Although there won't be files visible over here, but this will be a blank window which would be visible to you. Over here what you have to do is just click on file and import the project which I have shared with you. So there's a code base which I've shared with you people is so there's a folder called code which is shared with you that contains a folder called MapReduce and that contains a folder called MapReduce Maven project. So wherever you download it, you have to just click file, import, type MAV and Maven, existing Maven project, click on next, browse where your folder, browse where you have downloaded this folder code MapReduce and MapReduce Maven project. Browse it over here, it will automatically show you the projects available. Click on next and finish, and the project, this whole source code on the left hand side would be visible to you. Is it making sense to everyone, or I'm just going ahead and ahead?
Where was the code? Maybe I missed where the code was to download.
Okay, okay, okay. So I have shared, I think, three different, you would have received three different Google Drive requests. One would be for the software, one would be for the
What?
code folder, and one would be for the PPTs. You would
Okay.
have, so I
Let me
think you
make
would
sure.
have,
I
okay,
got the PowerPoints. Let me see if I've got the one for the code. Okay.
yeah, sure. Have a look. And there you have to just browse the MapReduce code and the MapReduce Maven project and just import it
Okay.
and how to use it. Once you people import it, I'll help you out how to use it. For those who are not familiar with Java, they would face a little bit difficulty, but I'll definitely help you out how to use it. So once you download the code, all you have to do, okay, so before that, one more complexity over here. Uh, Okay, so I think Raja, Puneet, Padmani, all you are not from the Java background, right? Yes. Okay. Okay. So what you people do is rather than importing this Maven project, you import this non-Maven project. Why? Because this will be easier for you to compile and run rather than this project. So you people use this Maven MapReduce non-Maven project. Over here, what you have to do is file, import. Rather than typing Maven over here, rather than typing Maven over here, just type Java. Oh, sorry, not Java. Existing. Um, just go to General, and there'll be an option called Existing Projects into Workspace. Click on Next. Browse this project non-Maven, and this will be available to you over here. Just click on Next, Finish, and the similar code will be visible to you. There will be no difference in the codes which I am seeing left hand side. And use this project rather than using the Maven project because you will face difficulties while running the Maven and installing the Maven. So this is easier for you. Use the non-Maven project. And I'll come to Shelly in a minute. Just give me a sec. So, Shelly, are you okay with Maven? Do you know how to use Maven, how to install Maven, everything like that?
Yes.
Okay.
I'm sorry. I was on mute. Yes, I'm fine with that.
So,
And let me check to make sure on the.
for
And I did
okay,
not get an
okay,
email on the code,
definitely not. No, don't worry. I'll resend it.
but
Not.
I can. Okay. Thank you. Thank you.
So just for you, Sally, uh, over here in the softwares, the Maven is also there, and the
Mm-hmm.
installation document is also there if you want to use it, and you can just compile it with MV and clean install.
Yeah, and I'm familiar with Maven.
Oh, you are not? Okay, so then
No,
better
I
you.
am. I am.
Oh,
No,
okay,
I am familiar with Maven.
okay.
So it's fine.
So I've misspelled the installer spelling, so you can just do Maven clean
That's
install, and this
okay.
will, yeah. So that will
Okay.
do it. And for the others, what you have to do is once you download this code base folder and import this non-Maven project, that will have everything you don't have to worry about. That is everything, all the libraries included, everything is there. And for you, how to do it is just click on this thing, file, export, and click on a runnable jar file and click on next. It will ask you to generate what you just say package required libraries to generate a jar, and from the drop down select the class file which you want to export of. Which class file you will be looking at, I'll just tell you in a minute, and click on finish. This will create a file whatsoever name you give over here at the corresponding directory which you have browsed over here, and this jar file will be using up to run our the Hadoop code. Okay, so I think most of you people not have received the code folder. Let me resend it in a minute. Give me a just give me a minute. I have to search your Gmail ID. Can you quickly ping me your Gmail IDs? Otherwise, you have to open another document to find your Gmail IDs. I'll share it right away. Please ping me your Gmail IDs on this chat window. I'll share it right away. So I've got Puneet, Shell. So Puneet, I'll just give me a minute. I'll repeat. Padmini, are you there? Not sure. Okay. So I'll again repeat what I said is, so I talked about two things: how to install the VirtualBox image. Any questions on that part? How to install VirtualBox image? How to import it?
No questions.
Okay, so Puneet had something up, I think. All good. Okay. So okay, I assume it's all good with that. So after that, I talked about how to install the Java related thing, how to use the Java code. So for the Java code, you have to do is download this Eclipse, download the 32-bit or 62-bit based on your laptop configuration, and just unzip it, nothing else, and there will be a file called eclipse.exe. Just double click it and this will open a window something like this, although a blank white window. Only these things would be visible to you. After that, what you have to do is you have to download this code folder. Inside MapReduce there is a folder called MapReduce non-Maven project. From here, file, you have to just say import. In the import you have to use general existing project into workspace. Inside general existing project into workspace, click on next. Browse this folder where you have downloaded this Maven MapReduce non-Maven project. Browse that. It will be, your project name would be visible to you automatically. Just click on next and finish, and that project will be imported over here, and you will see all these files over here on the left hand side. All the jars dependencies would be there automatically imported. Don't worry about anything. Once you've imported it, then we'll be using different jars which will be running into the Hadoop world. And how to create a jar, that I was telling right away. I'll again tell that step, but let me show you how to use that jar. And after that, I'll repeat the step how to create the jar, which we'll be using up to run the MapReduce code. So how to use the jar? So if everyone recalls or everyone remember, in the last class we talked about a program called which was reading files locally and creating creating a file in HDFS word. So it was reading a lot of small files locally and creating a big file into Hadoop word. And I told you that I'll be running this program in the next class and will tell you how to run it. So what to do is, so this program is there, merge local files into HDFS. So if you remember, this was the file which was merging a lot of things into smaller files into the big one. So this is a class file over here. Now what you have to do is, if you want to try it locally, you have to say right click and run as, but this requires a lot of Hadoop related things, so you will not be able to run it. But I request you to run it once over here, and the reason is I'll tell you in some time. Just try to run it locally over here, and this will give you an error something like this. When you say right click and run it, it will give an error something like this. So say it gave me a red color error, beautiful error. So because it cannot connect to Hadoop and a number of things. So but why I said you to run it, I'll tell you in a minute. So for Sally, I hope you will be able to create a jar with Maven. For others, so what you can do is you can just click on File, click on Export, click on Runnable jar, click on Next, and now this is the file merge local put to HDFS. So from the drop down, I'll select the file merge local. From the drop down, I'll select the file merge local put to SDFS. Merge local put to SDFS, and this would be available only once you right click and run it, so that registered it over here. Otherwise, that will not be visible in the drop down. So that's the reason I told you over here, right click and run it, so that it registers over here and that is visible to you in the drop down. And then I browse any directory where I want to create a jar. So I say browse, and now let's say in my downloads I want to create a jar, and the jar name say class 2305.jar, and I say package required libraries into generated jar and click on finish. What happened? No resource selected, or this resource is not merge local put to SDFS. So that was the old file which is deleted up. So this is the one latest one. So I selected the wrong file from the drop down and that gave an error. So it's exporting everything, creating a big fat jar file for us, and we'll be using that file to run the Hadoop MapReduce program. For Sally, once you run your Maven, there's a Maven project. So jar exported and jar would be available over there. Once you run it, there will be two jars which will be created. One is a fat jar, one is a thin jar. You can use a thin jar because all the dependencies are automatically imported into the Hadoop world. So you don't have to export that. So basically FTP the thick jar. So for others, I have just downloaded the file, and let me look over there in the downloads. And date. So this is a jar file. Now what I have to do is, again in the software folder, there's a software called winscp.exe. So this is nothing but FTP protocol FTP protocol software. So once you open it, it will be looking something like this. Over here, all you have to do is click on new. Once you click on new, this will be asking you for the hostname, username, and password. So hostname will again remain same. Port is 4 times 22. Username is you. Her password is Hadoop. And click on login. You can save it for future purpose, like I saved it and clicked on edit. And once you click on login, it will connect you to the Hadoop cluster again. And now you can drag and drop the file from your Windows to the Hadoop Unix machine. So on the left hand side, I can see my Windows. On the right hand side, I can see my Hadoop thing. So over here, I downloaded into the download folder. So in the download folder, this was the thing. I can just say drag it over here and drop it over here, and this will be available for me in the Unix box. So when I go to Unix box, and say ls, these jars would be visible to me. Now I'll be using these jars to run the MapReduce program. How to run a MapReduce program? Again, you don't have to remember anything. If you go to the Java files, each Java file at the end has a commented command. You can use it directly how to run it. So it talks about everything how to run it. So you can just Control C and right click over here. Ensure that you change the the file names because you on your desktop these file names would be different. So in this program, if you remember, what I was doing is I was reading something from the local directory. I was creating a big fat file in the LGFS world. So the first input is the local file, input file. If you remember, I got the local first thing as the input and second thing as output, where I want to put in the output. So first path is the local path and the second path is the output file which I want to create in the Hadoop world. And here I have to give the class file name and the jar name. So jar is already, I have dragged it onto the Unix world. What I have to say is Hadoop jar name, The file which I want to run, for those who are using the non-Maven project, don't have to give the file name like the way I have given over here. Input file and output file which I want to create in the Hadoop, and press enter. So this will read the file locally and will create a big fat file into the SDFS board. So by the time this is running, I request everyone to just frankly ask me all the questions which you have, because I have gone little fast and I hope you would have a lot of doubts, confusion. Please go ahead and ask me the different questions which you have by the time it's running up at the back end. Or if you want me to repeat, do let me know. So Sally says, just a minute, I'll read a question. I'll just find out some files which I can copy it over there. So it gave me an error. So I'll just give a single file over here right now. So what I'm saying is Hadoop, jar name. So, and the class name which I want to run. For those who are creating the jar from Eclipse, you don't have to give the class name, the input file which I want to copy into SGFS. So I am giving right now one single file. You can give a folder, but there are a lot of files in this folder, so I don't want for it to run for hours. So I'm just giving one single file. Oops. Oh man, sorry. I pressed enter in between. And the place where I want to create the output file. So I want to create it over here. Sure, Raja, I'll repeat it by the time it's running up. So I'll read your questions one by one. Will you provide a link to the recording if you want to? Yeah. Shelly, you can just drop an email. I'll share to the email ID, and you will get the link. Puneet, what is the utility of this jar file? Okay, please repeat the non. Okay, I'll repeat it. Just a minute. So it gave me an error. The output directory already exists. I have to remove it. So Hadoop fs minus rm minus r, and the file which I want to remove, and the file is deleted. Padmini, are you there? Looks like she's away. So okay. So Raja, I'll repeat for you the non-Maven steps. I'll just check the file is not copied. I'll just cross check why the file is not copied in a minute. Before that, I'll repeat the steps. So Raja, can you quickly unmute yourself and tell me till what point you have understood, or do you want me to repeat everything?
Yeah, I think for non-Maven, first we have to install that in code MapReduce. We have a non-Maven, and we have to go to this and file and import the that existing project. So from there, can you please go ahead?
Okay, okay. So you have to you have to open Eclipse. For Eclipse, you can just download the Eclipse folder from the softwares and just double click on the exe file in that folder. That will open this thing. You don't have to install anything. Um,
Okay.
Click on File, click on Import, and in the general, there's something called existing project into workspace. Just click on next. Browse the MapReduce non-Maven project over there, and this will show you the project over here automatically. And just click on
Okay.
finish. You don't have to do nothing. Just click on finish, nothing else. And once you do a
Okay.
finish, this will look something like this only on the left hand side. On the right hand side, you can just double click on any file and open it.
Okay.
Okay, so this will open all the files which are there in the code base. There are a lot of files. Don't worry about different files. There's a lot of code which I keep on sharing with people. So there's a lot of code over there. So this is on the left hand side. So now you'll be requiring a but basically what you have to do is you have to create jar files to if you remember the job tracker task tracker part, if I have told you, so we have to give the logic to the job tracker and task tracker to run our program. So this jar is basically nothing but
Yeah.
the logic which we have zipped up in a file. So
Mhm.
this class is my logic. So I've zipped it so that Java can understand it, and I'm sending it to the Hadoop world.
Okay.
Okay, so how
So
to
now, yeah, now how to make a jar file, right? We have
Okay,
to.
okay. So how to make a jar file or that logic which you have to send it to Hadoop World. So you have to write your Java program. So don't worry about writing the Java program. You won't be writing it up, but how to use it. The Java program which I've shared with you. Click on File, click on Export, and inside Java there's something called Runnable Java jar. Runnable jar. Click on Next. From the drop down, select the file which or the logic which you want to trigger up. So in each file you'll be writing some logic. So from this drop down you have to select your corresponding Java file which logic you want to run. In the browse you just browse the directory where you want to put this jar or the zip file which is created out of this export utility, and select the second option, that is package required libraries into generated jar, so that all the dependencies are there in your jar, and just click on finish,
Okay.
nothing else. And the
Okay.
jar would be created at this location whatsoever you have browsed it over here and the name which you have given over here.
Yeah.
Clear till this point
Yeah.
to everyone?
Yes. 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 Yeah,
Puneet,
I got
Padmani?
it. Maybe. Yeah. If any doubts while creating, maybe I will let you know after that.
Yeah, sure, yeah, sure. Definitely, everyone, please try it out after the class, and we'll discuss your problems that you're facing tomorrow. And I'll give you the controls if you are not able to do it. I'll help you out how to do it in your tomorrow's class, and you people can just try it out in your today's time. Yes, Puneet, this jar is the logic which we send it to the job tracker and the task tracker, which is basically ran up. So the logic is written in the Java language over here in the MapReduce code. So till now we have not produced any MapReduce code. Till now we have just written one program which was reading local files and writing it to SDFS word. So this is again a logic which will be talking to SDFS part. So this is saved as MapReduce code only. So I'll just quickly check why it did not run. Oh, okay. So it was requiring a directory, and I gave a file, and it was looking for the files inside this directory, and there was no files. So that's the reason it did not did anything. Uh, okay, we'll try another program. I don't have right now. So this is nothing. This is a small again program which where I'm doing what I'm doing is I am reading a file from HDFS. So I gave the path or the file which need to be read up, and I've created a open stream from that file and writing that on the screen. Nothing great. So what I'll do is I'll again create a jar and we'll put it over there and we'll try to use it. So guys, I'm not running that program because right now I don't have a lot of files in a single directory. You can try it out and there will be no problem with you people. So I have given the class name which need to be triggered up for the people who are using not using Maven. You don't have to give this file name. Please remember it, you don't have to give the file name because your jar is already a runnable jar. So this is the file which I am trying to read from the SDFS world. If this file is not existing, it will give me an error. It will give some another file, but I hope this file would be there. So by the time we'll check on the Hue UI if the file is there or not. So let's go to the Hue UI browser, click over here, click over here. So yes, Puneet, this jar is not a MapReduce. MapReduce we'll be talking about in some time. Before that, I was telling you how to use the softwares. MapReduce I'll talk about. This jar is nothing but this is an this is a jar which is using SDFS package to interact or communicate with the SDFS file system. This is not a MapReduce. Okay, so unfortunately this file is not open. So this file is printed over here, and this would be the same file. Oops, यार क्या देने मैंने. So the file name was text.txt, and see this is a file which is printed over there. So it communicated to the SDFS word and printed it. And same I would have done with. Can anyone tell what I would have written over here to do the same thing, to read this file or to print this file over here? Right now I have written a Java code. I have used the Hue UI. What is the third option I can do? Puneet, can you send me the whole command? What to do? Not exactly correct. Anyone else remember it? Hadoop fs minus cat and file name. So that will again communicate to the Hadoop file system and will do the same thing what I did in the Java program or what I did from the Hue UI. So the same file is again printed over here. So any questions from anyone how to use this different software which I have shared with you before I move on to the real MapReduce world? Password for the Hue UI. When you open the Hue UI for the first time, it will print the password on the same browser page somewhere on top or bottom. Just read that page carefully. You'll be able to see the password of the Hue UI. The user is you. Okay, so I assume no questions from anyone. I'll move on to the MapReduce world. Okay. So guys, again, I'll be going slowly and slowly. On each slide, I'll be talking about different aspects of the MapReduce so that you can digest it. Otherwise, it would be, if I tell everything on the first slide, it would be totally undigestive session for you. So I'll slowly go, and on each slide I'll try to explain, add up few things. So as you can hear, map reduce, these are the two different terms. Something is called map and something is called reduce. So this whole program or all this whole data processing happens in two steps. One is called mapper phase, one is called reducer phase. Mapper does some logic on your data, reducer does some logic on your data, and the final output from the reducer is the real data which you want to look at. So whatever logic which we want to use to process the data, we have to define it in two steps. One is called map step and another one is called reduce step or reduce phase. So the name signifies map. In the map phase, what we try to do is we try to map a similar data to a similar to a similar key. So okay, before I go ahead, does everyone understands what is key and value pair? What is hash map? Others? What is key and value pair? What is hash map? Does everyone understands? Okay, Puneet says no. What about others? No. Okay. Okay, first, okay. So before going into MapReduce, let me quickly explain you what is key and value pair and what is hash map. Otherwise, MapReduce does not make sense to you. That will sound Greek to you. So just give me a minute. Okay. So uh, Raja says book index kind of thing. Yeah, you can say it. Yes. Okay. So say I have some data. This hash code could be anything. So there are universal different hashing utilities available. There are different hashing utilities used in the MapReduce world also. So this hash code could be anything, which could be running on your input data and will be giving a unique hash value out of your data. So this hash code could be anything, and the output value of your data would be a hash key of your data. So two data sets could also have a same hash key, but how that is used, we'll talk in some time. So let's say the hash code which I'm using is nothing but say sum of my digits. So that is the hash code of my data. So sum of the digits is my hashing function. So the hash value of this is nothing but 3 plus 2 plus 4 plus 2 plus 3. Hash value of this thing is 2 plus 3 plus 4. Hash value of this thing is 5 plus 4 plus 6 plus 5 plus 4, and so on. So these are the different hash values assigned to these numbers, and they are assigned. So hashing is basically used to bucket your data. So the similar hash value means your data is similar, and that could be bucketed to a similar bucket, and that is used in the hashing functions or hash maps. So what hash maps do is they create a hash value or a hashing code on your key, and your values go to the place where your similar keys lies up. So what you have to do is you have to divide your data into keys and values. Let's say my data is employee table. So I'm using the same example, and it has employee ID, employee name, employee department, and so on. ID is 2, 3, 4, 5, 7, and so on. Name is and so on, and department, so on, so on. Okay. So now I can give some key to this data and some value to this data. So you have to divide your data somehow in keys and value pair. So here I can safely say the ID is the key of my data. So 2 is the key of this row, 3 is the key of this row, 4 is the key of this row, 5 is the key of this row, 6 is the key of this row. So you have to divide your data somehow into keys and value pair in the mapper phase. So mapper phase is nothing but in that phase you have to divide your you have to define some unique key for your row by which you will be identifying your data, and that key would be used at the reducer phase to do some grouping on your data. So let's say my query statement is I want to find out number of employees in a department. I want to find out number of employees in a department. So what I can do is I can say my key is department. So let's say it was IT, and let's say it was HR. And it was IT. Okay. I want to figure out number of employees in each department. That's my problem statement. Somehow in the MapReduce code I have to do it. I'll explain the MapReduce code in detail to you, but in this example I'm just trying to make you feel what is key and value pair, how that is used. and what is hashing, where hashing comes in picture. So what I'll if I want to find out number of employees in each department, rather than using this ID as a key, I can use key as a department. So in that case, the yellow color data is a similar data. The yellow color data is similar data, and the orange color data is again the similar data. And if I can group this data in such a fashion, I can easily count the number of employees in HR department, and I can find out the number of employees in IT department, right? So I have to find out a key in my data which would be unique for my problem statement. So that is your beauty of your MapReduce. That is what you do in the mapper phase. So in the mapper phase, you have to find out some particular value out of your data, which would be unique for you to do some logic on your data, which is the thing which you want to run on the data. So here the problem statement was, I want to find out number of employees in each department. In the mapper phase, what I'll do is I'll say this is the key, that is the department is the key of my data, and rest is my data. So mapper will emit something like this key. So all your MapReduce code talks in keys and value pair. So you have to define some key on your data, you have to define some value on your data. So all at the backend, everything is written as in the file system as a comma separated say. So that will read it something like this: 2, Sally, IT, 3, Padmani, IT, 4, Raja, IT, 5, Puneet, HR, 6, Miraj, HR. But in your MapReduce code on the mapper side, what you will say is my key is department, so key is IT, and my value is Shelly, 2, key is IT, value is IT, key is again IT, and value is 4 HR, comma 5 HR. So your mapper code will write a logic and will define some key for your data and some value for your data, and this we'll be using in the reducer phase to find out number of employees in each department. Oh yes, sure, Padmani. Sorry for that. Yeah. So somehow we have to find out a unique key on which we want to do some grouping or some logic which we want to run on the data. So mapper would everything in this word talks in keys and value pair only. If you can think what will be the key for your data, what will be the value for your data, your 50% of the MapReduce problem itself solved. If you can think of what is a key of your data, what is the value of your data out of your data, your out of 100%, your 50% of the problem is already solved. And if you start thinking in that direction, it will be very easy for you. It's nothing, it's a child jobs. But you have to change your mindset to think in keys and value pairs. So now what I said is my key is the department, and the value is the rest of the data. So this is output of your MapReduce mapper phase. Okay, so hashing is related to. So Puneet, I have just told you the concept of hashing. I have told you the concept of keys and values. Just wait for how hashing is used in the MapReduce phase. For a few minutes, I'll explain you that thing also. But do not forget what is hashing, and hashing is used to bucket your similar data. How that is used, just wait for some more time. I'll explain that part. So mapper said this is my key and this is my value. Some magic happens at the backend, and your data reaches your reducer. Some magic happens at the backend, your data reaches reducer. On the reducer, what I'll say is, I'll say key and value, and some magic happens at the backend. What I'll get on the reducer is something like this. What magic happens, I'll explain you in some time. One minute. So what I'm typing will be visible after I press enter. I am just behaving lazy in typing out the things, and I'm just printing the formula. Okay, so some magic happens at the backend. Your data reaches something like this to your reducer. HR, and over here Padmani won't be there. It would be just uh, J 20 21 and 22. Some magic happens at the backend, and your data reaches reducer somehow like this. So reducer will get a key and the list of values associated to that key. Reducer gets a key and the list of values associated to that key. Some magic happens at the backend. What happens? Don't worry, we'll be going on to that slowly and slowly. And on the reducer, what I'll do is I'll write a simple Java code to find out number of values and print that. So over here I'll group through all the values and just say IT, and number of values in this list is 3, print it. HR, number of values in this list is 2, print it, and my everything is done. Does this whole flow make sense to you a little bit? Do you understand what is key, what is value, and somewhat what is happening on the mapper side, somewhat what is happening on the reducer side?
Yeah, it makes sense.
Makes sense? Okay. So let's go to the MapReduce now. And there's something called hash code or something called hashing. Just keep in your mind, somewhere back of your mind. I'll come back to that thing in some time. Okay. So your mapper emits some keys and value. Reducer digests those keys and values and emits some. So as the name suggests, reduce, that reduces the thing. So that do some aggregation or summarization on your data and produce the summarized or aggregated output. So all your summarization aggregation parts basically happens on your reducer phase, as the mapper itself, the name suggests, that maps the similar keys. So that maps your similar data. And how that maps your similar data? You have to produce similar keys for your similarly intended data. So in the previous example, my similarly intended data was the department, the data which was sharing the same department. That was my similar data. So my key was a department. If I were to do something else, I would have made that as a key. So everything talks in terms of keys and value pairs. So mapper read the data in key and value only. Mapper emit the data in the key and value only. Reducer read the data in key and value pair only. Reducer emit the data in key and value pair only. So there are 4 pair of keys and values. One what mapper reads, one what mapper emits, one what reducer reads, one what reducer emits. So in the previous example, we have seen only 3 keys and values. One is what mapper has emitted, one is what reducer has what was the input to the reducer, and one was what was the output from the reducer. But we have skipped what was read from the mapper. So in this example, the way it will be read for the input for the mapper, it would be something like this. So mapper would be reading it in the key and value pair only, but the key in that case would be some dummy value. So that would be again some magic happens at the backend. We'll talk about all these magics. For a time being, just assume that is magic only. I'll talk everything in detail, but I don't want to confuse you on the before even I do not start the MapReduce code. So some magic happens at the map at the back end, and your the key would, to your mapper would be some magical keys, and these magical keys are no sense to me. Does not make any sense to me, so I'll just ignore them. Okay, so somehow some magic happens at the backend, and these keys are automatically created, and the value is nothing but your data is the input to your mapper phase. So this is input to mapper. This is what mapper produced. Output. So this mapper, this all phase is mapper only. So, and this all phase is your reducer. So this was input to your mapper. Some magic happens, and these keys and values are created for your values. The value is nothing but your data. And I did some logic. I wrote some logic in the MapReduce code to create the keys which are intended for me, or which makes my data logical to each other. Some magic happens in the, over here. In the green box between mapper and reducer, this is the input to a reducer, which got your similar keys grouped together, and the reducer then output the things again in the keys and values only. And in this case, now your key is the department, and the value is nothing but the sum of employees in the department. Okay, so everything is read and basically communicated in keys and values only. You read the data in key and value, you output the data in key and value from a mapper. That data goes to reducer in key and value only. Reducer emit again the keys and values only. Clear till now? Okay, sure. So I'll assume a yes from everyone else. So I read the data. There are two phases, map and reduce. I read the data. That data passes in this magical phase, what we call short and shuffle phase. So there's a third phase which I'm talking over here right now. This is the mapper phase. This is your reducer phase. But in between, this is called short and shuffle phase. This is a magical phase, the green box which I've highlighted in the Excel sheet. So we'll talk about this short and shuffle phase in some time. And this is this magical phase basically, combine those similar keys and then send it to the reducer. So now let's look at some other example that will give you more insight of what is map and reduce. So the problem statement is, I want to count number of colors in my input data. So on the left hand side of this PPT, you can see that there are 4 different SDFS blocks on which my data is segregated. So my data is lying right now on 4 different SDFS blocks because my file was of big size. So if you remember the task tracker and the job tracker, on each node where this block is lying, your program would be running up. So when I say my program would be running up, only my mapper code would be running up. So a mapper would be running up. So if you remember in the last class, I said a mapper for each split, and assume the split is equivalent to a block. So 4 blocks over here, 4 mappers. And what is split? What is split and how the split is different from a block? I'll explain you also that too in some time. So number of blocks over here are 4. So 4 mappers would be created up, and those mappers would be emitting keys and value pairs. So they would be reading that data with a magical key, and the value is nothing but your color. So four mappers are created up. What are those magical keys? I'll again come to that, but slowly and slowly. I don't want to you to I just don't want to bombard you with the information. So mapper reads the data and emit key and value pair, and I hope now you can easily guess my key would be the color and the value would be the count of the color. So my intention of this map reduce code is I want to count the number of colors in my input file, and the colors could be blue color, green color, brown color. So these are the only three colors which I can see. So mapper is emitting the color as a key, and the value is the count of the color. So I'm reading one by one, so count will always be one, which will be emitted by the mapper phase. So it will keep on emitting color comma one, color comma one, color comma one. So all the mapper will emit their data respectively on their nodes. In this magical phase, that data is merged together and that reaches the intended reducers which are working on that key. So in this example, I highlighted three reducers, but there could be different cases. I'll talk about that in next few minutes. So for a timing, assume there are three reducers emitted in this program or used in this program. So the blue color reducer is working for the blue colors, brown color reducer is working for the brown colors, green color reducer is working for the green colors. So your green, if you can see now, the blue color keys are sent it to the blue reducer, brown ones are going to the brown reducer, and green ones are going to the green reducer. And similar thing will happen from the other mappers also. So your similar keys will reach the similar reducer. And this is where hashing comes in picture. I'll again come to that part in a minute. Just wait for a minute also, a few more minutes. And the reducer, well, now reducer has all the keys for a similar color. They will just do the count of the values and emit the values. So a reducer got it something like this: keys and all the values. They just counted it and produced the keys and values. So blue comma 100, brown comma so and so, and green comma so and so, and that is emitted to your Azure file system, and you will get three files. Each file will have a count of one file will have a count for blue color, one file will have a count for green color, one file will have a count for brown color. So before I talk about other things, hashing and other things, this magical phase and the magical keys which are created for input mapper. Any questions? Anything? I want someone of you to repeat everything, but I talked on this slide before I go ahead. So who want to go and then explain everything again?
This is Sally. I can explain it.
Sure, go ahead.
So we have our different input blocks on the HDFS. We have a map. We write the map and the reduce. The mapping is going to take all of the blues and that the key is blue. The value is 1. So for each blue that we have, we'll have a key of blue and a value of 1. And then the Hadoop code will do the shuffle and the sort based on the key. All of the blues will be put together in the reducer, the reds and the greens, and then it will sum it up and say how many keys. We'll create a new key that has the sum of all of the values. So in this case, we would have, let's say, 100 blues. And then that gives us the sum.
Yes, perfectly fine. So, is it clear to everyone? Padmini, Puneet, Raja, that gives you a highlight of what is MapReduce, how basically it happens at the backend, how that all the processing happens at the backend. I want to listen a quick yes from everyone. Okay, I got a yes from Puneet. As of now, yes. What does that mean, Padmi? As of now. So I am not able to understand as of now of yours. But if you have any doubt, just ask me right away. Okay. So, okay, Puneet, I'll just wait. I'll be explaining your question. We have four notes, three. I'll be explaining that part. Just wait a minute. Mm, any other questions? Okay. Okay. So in this example, I just assume there are three reducers created. However, based on the Hadoop system configuration, the number of reducers which are created could be 100 also, could be one also, could be 100 also, could be one also. But your similar keys would always reach a similar reducer. So if there are 100 reducers created in this example, that does not mean that blue might go to some other reducer also. That will always go to a reducer which is scattering a blue key. So if one mapper has sent a blue key to this reducer, all the other mappers will be ensured to send all their blue keys to this reducer only. So for example, there is only one reducer created in this scenario, then all your blue, green, and brown. So let's say these are not the reducer. So this reducer is handling all your keys. So in that case, all your blues, browns, and greens will be sent to this reducer only. But in that case, this reducer function would be called thrice, and one time it will be summing up for blue, one time it will be summing up for brown, one time it will be summing up for green. So in that case, only one file will be outputted up rather than the three, because the number of files outputted on SDPS word is always equivalent to a number of reducers. So there will be only one file, and this file will have all the counts: blue, 100, green, 200, and brown, 500. So number of reducers which will be created in your program is dependent on your Hadoop configuration, that is nowhere related to your number of blocks. The number of mappers created in your program is equivalent to your number of blocks or number of splits. What is split? Just wait for that thing also for some more time. Uh, Hey people, can you hear me?
Yes.
Sorry, I think I did some mistake or something. I got disconnected. Sorry. Um, Sorry, I think I don't know. I pressed Wi-Fi button or what. I got disconnected. So I was saying something. Mm, So where were we? Oops. So I've closed the PPT also. Raja, I think I got disconnected. Sorry for that. I hope you can hear me now, right? Yeah. Sorry, I got disconnected in between, I think. Mm, so the number of reducers is dependent on your Hadoop configuration. There are different parameters which are getting evaluated before Hadoop decides what are the number of reducers required in your program. So number of reducers could be 1 also, number of reducers could be 10 also, number of reducers could be 100 also. So now the hashing comes in picture, which I was talking previously. So this hashing ensures that your similar keys reaches a similar reducer. So if I go back to the Excel sheet which I've created, so if you remember, the hash code which we were using was say sum of the digits. So so this will have 9, this will have 9, and say this has 333. So this will also has 9, and say this has 6, 4, 10, 15. I'll make it little change. I'll make it 4. So this has 14 and so on. So over here, this one and this one are having the same hash code. This one till this one are having the same hash code, and this one also. And this one is having another hash code.
Uh, that is hash value, right? Code.
Yeah, hash value. So now the yellow ones would be catered by one reducer, that is a hash value which that reducer is catering up. The green one would be catered by some reducer which is catering the hash code of range of this thing. And so basically what happens up is at the back end there are reducers created up, and each reducer would be catering a bucket of hash codes. A bucket of hash codes. So now say the reducer 1 is catering bucket from say 0 to 10. Reducer 2 is scattering bucket from say 11 to 21 or 22. And reducer 3 is scattering say 23, say 100. So that is the maximum, say for in this example. So 2, 3. So now the yellow ones will go to the reducer which I have highlighted in yellow. The green ones will go to the reducer which I've highlighted in green, and the blue ones would go to the reducer which I've highlighted in blue. Okay, so now you can see the 24 is lying in the bucket of 20 to 100, so that will be going to the R3. Similar thing happens to your keys which are emitted from your from a mapper. So that they are reducers which are created automatically in the Hadoop world, and the reducers will be intended or will be catering a bucket of hash codes. So the hash codes are nothing but a hash value of your key, not the value of your key, and our reducer will be catering a bucket of those things. So in this example, although I have created three reducers for each color, but there could have been two also, there could be have had been 100 also, there could have been one also. So in that case, the hash code of blue would be going to the reducer which is intended for the blue one, and similarly for brown and green. So this short and shuffle phase, the magical phase which I was talking previously, ensures that your similar keys reaches your similar reducer based on the hash value of your key. So Puneet, does it answer your question now? Any other questions? Anything else anyone want to ask? So number of files which will be created as an output of HDFS word is always equivalent to a number of reducers triggered in your program. So in this case, in this example, on this PPT, there are three reducers. So there are three files. No, Puneet. There could be 1,000 also, but if in the sample set we have just say three colors only, so rest 997 would be not doing anything. The number of reducers would be created based on your input data size and different factors which are again configurable, and how skewed are your keys. So that all those factors are taken care while creating a number of reducers, but there could be 1,000 also in a worst case scenario. And in that case, only three would be doing their job, or might be only one might be doing its job, and rest all 999 might be idle. Okay, so this is happening in your short and shuffle phase. Your similar keys are getting hashed and going to the similar reducer which are intending those values. And then the reducer will just do a count of them and will print the output as a count of number of colors available. So I'll quickly next. Okay. So now can anyone explain me this whole process again in the terms of job tracker and a task tracker? Now we talked about how the processing happens in the backend, how the files are there, and how your logic runs in the terms of map and reduce thing. So I want someone to group together everything, all the information now is there with you. You to group together to explain me what happening in terms of task tracker, job tracker, blocks, if my file is divided, replicated, all those things taking place.
So I can give it a shot if you like.
Yeah, please go ahead.
Okay. So we've got our files that are in a HDFS. They would be replicated. They would be replicated onto the different nodes. And so, as we talked about last time, there would be 3 replications, 2 of them usually on the same rack, 1 of them on a separate rack. The job tracker is the overall brains of the system that would be organizing which code is going onto which different node. On each node there would be a mapper, and there would be a task tracker on each node that would be keeping track of what jobs will be running. As the sort and shuffle happens, there will be,
Okay, so where the short and shuffle happens, that I'll explain. Yeah, that I'll explain where that happens basically. So that I'm not talking about.
Okay.
Yeah.
Okay.
And then your code goes to the reducer, and reducer will again be triggered from your task tracker.
Right.
So now everyone is able to, picturize everything what I'm talking till now from the last three classes. Are you able to combine other things? Does it make sense now?
Mm, no, I understand. Maybe let me brief.
Sure,
So
sure,
this
sure.
map and reducer maybe will be part of only the task tracker, right? So
Yeah,
job
job
tracker,
tracker just coordinates the things.
yeah, job tracker will be on top of it, and the once the task tracker starts in the task tracker, we have a mapper, we have a reducer, everything, isn't it?
Okay, so reducer might not be running on the same node where your data is lying, because now you see, although in the input I have four blocks, but there are three reducers. So the
Yeah.
reducer might be running somewhere else also. So in that case, this data is transferred over the network to reach the reducer node.
Okay. No, I am just
Because
correlating and simulating the picture of job tracker and task tracker. So,
Mhm.
so where it lies then, this map and reducer.
Okay, 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 okay. So let me go to the Excel part again. So now, like, I'll also explain you the split also while I'm going to the this thing,
Yeah.
Excel sheet. So there's something called job tracker JT and task tracker TD. So now, say this is your block one. Um, Text in red color is your block one. Text in brown color is your block two, and text in black color is your block three. Okay, B1, B2, and B3. Okay, so these are the different blocks on my data. So my data is divided into these blocks. So let's say B1 is there on your data node D1. So and say D5 and say D7, and similarly the other ones also. So now what your job cycle will see, oh, D1 is free. I can assign the B1's mapper task to node D1, and let's say B2 is replicated again on D1, D3, and say D7, and B3 is replicated on say D3, D7, and say D9. Okay, so now job tracker we have assigned say B1 to D1, D1 to run the mapper for B1. Now it sees D1 is already running something and it might not be having that much memory, so it might assign it to say D3. Now D3 is also running, so it might assign to the for the block 3, it might assign to D7. So this is what job tracker will do, just assign the task to these nodes to run it. And when it's assigning the task, it's just the mapper task which is assigning. So that's the reason in the previous slide, job tracker task tracker slide, if you remember, I said number of mappers is equivalent to a number of blocks or number of splits. So there are three mappers initiated on the node D1, mapper 1, mapper 2, and mapper 3, which are being ran on these task tracker nodes and doing the data processing and basically emitting keys and values like this. Make sense till now?
Yeah, Miraj. So yeah, so mapper will be definitely coming into
Coming. Okay.
task tracker. Yeah.
Now what will happen is these mappers, this short and shuffle phase, what is this green color phase, short and shuffle phase? Short and shuffle. So I've uh, show the what the short and so this short and shuffle phase will ensure the output of this mapper is divided into corresponding hash buckets and reaches the reducer. So now data node 2 was idle. So task job tracker saw it, and job tracker says data node 2 to task tracker to run, please run the reducer 1. So data node 2 task tracker will run the reducer 1, and now the job tracker knows that your D9 is also lying idle. So say this is task tracker to run the reducer too, and it sees based on the input data there are only two reducer which can do my job. So now this mapper data would be transferred over the network to this data node 2. This mapper data will also be transferred to these two nodes. This mapper data will also be transferred to these two nodes. But when this mapper is transferring the data, so let's say reducer 1 is scattering your hash keys, say hash bucket which is scattering is say 1 to 100, and this one is scattering say 100 and 1 to say 5000, that is the max one, or infinity. And the hash value of your IT is say 20, and hash value of your HR is say 201. So okay, so your IT will go over here and your HR will go over here, right?
Yeah. So that is the final.
So now if you again recall my previous slide, the map reduce slide, so this will go to over here only. Okay, so this mapper is processing these two records. These are IT intended, so that will only go to R1. This mapper is emitting these two records, that is your that is your IT and HR. So one record will go to your R1 and another record will go to your R2. And this mapper is processing only this record. So the only one record which is produced out of here will go to R2. Make sense? How the data transfer over the network from the mappers to your reducer?
Yes, yes, yes.
And now the reducer got all the data. It will run the reduce function, do the reducing of your data, and will emit the output. So I hope it's clear to everyone. If any questions, ask me right away. Yeah, data transfer takes place. How to reduce that? We'll talk about that. We will talk about that thing in advanced map reduce. How that to be reduced up, but definitely data transfer happens. Yes. Okay. So let's look at another map reduce program, and then I'll explain you this split part. How the split is little different from the block, because that would make you little bit more clear of the map reduce word. So mapper consumes keys and value pair, produce keys and value pair, reducer consumes keys and list of values, because all the similar keys are grouped together, and produce keys and value pair. This I have explained to you over the Excel sheet. And in between short and shuffle phase, ensure that your similar keys reaches your reducer, which is intended for digesting those keys, or processing those keys. So there could be some cases where you don't want a reducer. You can directly emit the output of your mapper phase to your SFS word. So say you want to do some, just some processing on the data only, you want to change the way your data is looking like and things like that, you can think of those things. So in that case, so they basically all I want to say on this slide is there could be some cases where you really don't want to reduce your data, you want to just say process all your data somehow. So your data might be directly emitted from the mapper phase to the HDFS word, and your number of reducers are 0. So again, all these things are configurable, you can configure these things. How to do that, we'll talk about that thing, but I'm just trying to make you visualize how things happen over here. So this I have again talked. I've already told you right now. Mapper reads the keys and value pair, and okay. So I was talking about the magical keys. Okay. So what are those magical keys which were created over here for the input of the mapper? I'll use some other colors. So okay. So these magical keys are nothing but when you read the data, so there's a process which reads the data from your HDFS file system and call your mapper function or the function which I've written to process the data in the mapper phase. So the guy which reads this data assigns the key to this data which is read from HDFS, and that key is nothing but the byte offset of that value in the file system. Now what is byte offset? So byte offset is nothing but the number of bytes by which this key is offsetted in the file. So if you can see, the key of the first record is 1 because that is the first position on my file. Now if these are total 22 bytes, so the key for the next record is 23, and if these in total are 44 bytes, so this the key for the next record is 45, and so on. So byte offset is nothing but the number of bytes offsetted or prior this record which I am reading right now. So this is the magical key which is created while you read the data, and in most of the cases this key really does not make sense to me. Although I can change the logic to read the data and I can create my own keys while I'm reading the data, but if I'm using the default logic to read the data, you in most of the cases you will be just ignoring these keys blindly and will be using just working for your on your value and would be producing your own keys and value pair out of your mapper. So what does this magical key make sense? Okay. So the mapper reads the keys and value pair, and what it reads is this keys and value pair. I'm ignoring these keys and outputting these keys and value pairs. So mapper outputs some keys and value pairs. This is what I said on this slide. Reducer get them. So reducer just a minute. Reducer got them, but in the keys and value pair format, and produce the keys and values pairs again. And produce the keys and value pairs again. Okay. So this is what I've said on this slide. Let's look at another example of this is called hello word of MapReduce, counting the number of words in a file. So this is a hello word of MapReduce. Whenever you Google MapReduce, you will always find this as a sample program everywhere. So here where my criteria is find out the number of apples appearing in the file, number of different fruits appearing in the file. So in other words, I am just counting the number of words in my file. So my file is divided into two blocks over here, the block 1 and the block 2. The block 1 will create mapper 1, the block 2 will create the mapper 2 on their respective data nodes out of the three application factors on any one of the data nodes where they are replicated. So my data is read record by record. Here my record are separated by slash n, that is a new line character. So one line is read and the key to that line is ignored in this example. So that is not visible over here. And you read the data in the key and value pair only, but the key is ignored because that was of no use to me, and I'm reading the keys and value pair. The values are line by line, so each line is a value. So your default reader basically reads line by line only. We can change everything. Everything is configurable in this word. How to change those things I'll talk about in my future classes. But for the time being, the default one is slash n. So slash n is your record separator. So your values are the key and value pair. For each record is a key and value pair, and the record separator is slash n. That is a new line over here in this example. So I got the keys and values. Keys are not visible on this slide, but those are the dummy keys which were given to your data. And on the mapper, I am emitting key as a fruit and value as a 1 because the count is 1. In the sort and shuffle phase, it ensures that your similar keys go to a similar reducer. So apple goes to a reducer, goes to some reducer, mango goes to someone. They did a sum and printed those as an output. And I got the number of words or so number of counts for each word appearing in my file, or number of count of each fruit appearing in my file. Makes sense to everyone, right? Okay. So now let me explain what is split. So till now everything clear to everyone, right? Okay. So now let me explain what is split. So now split will make sense to you. Okay. Now let's say this was my data, and in my name, say there was slash n character. So slash n was my separator. So in my name says there was slash n character. Or let's leave that. So let's I'll take a comma some easy example. So let's say I'll take this example only. This apple, orange, mango wala file only. So apple space orange space GRA. Now my blocks have a 64 MB only. So till now that the date GRA PS orange APP, now 64 bytes are over. So my data rest APP LE will go to next block. So there's your block 2 LE and GRA PS, now slash n, new line. ORNG, another line, some fruits, apple, some fruits say guava, APP, LE, OR, and 64 bytes are over. NG, APP, LE, GRAPES, and in the new line say that's all. So this is my file. 64 MB block 1, 64 MB block 2, might be less than 64 MB block 3. Now when my mapper 1 is running on this block, if it's doing its logic, practically thinking it will not be able to produce the right word count, it will produce APP1. That is not a full name. Everyone agrees to this part? If I'm reading block by block? Yeah, so that's where the logical split of the data comes in picture, or what we call a split. And that's the reason I was keep on saying number of mappers is equivalent to your number of splits, not the number of blocks. So what is my split now? So a split is a logical division of your data. So in this case, my split is something like this. So I'll split my data logically rather than physically. So, oops. Control X, Control V. Control X, Control V. F2. So this is your block 1, blue one is your block 1, red one is your block 2, and your this one is your block 3. So I've just divided that to Excel cells, nothing else, but the block is same. So okay. So now you can see the mapper one is extending from block 1 to block 2, and it will read this data also. And this is a logical division of your data. To till the time slash n or a new line is not appearing in your file, that is set to a logical division of your data. So you can define what is your logical division of your each record. By default is a new line, so it will read this data till now. So what will happen on the block one where your mapper is running up? Once it start reading, so once your reader starts reading this file, it will see it is not ending with slash n. It will interact to your name node, ask him where the next block line. Name node will return him where the next block is lying up. From that node, it will start reading the line till the time slash n reaches up. And this data, the one highlighted right now with orange color on my screen, I'll make it some other color. Uh, uh, Green color on my screen would be transferred over the network from this data node where a block 2 is lying up. So let's say it's lying on data node 2, data node 2 to your data node 1 where your block 1 is getting processed. And this is how all your intended data which is intended for your mapper to run up will be ran up. And even if your logical physical division of your data is not in a fashion on which you want to run the logic, that will automatically taken care by the Hadoop word, and there will be some again data transfer over the network. And this is how your split comes in picture. So your one split is this thing, what I've split it as a S1, and another split is this thing, and another split is this thing. So these are the three splits, and one mapper for this split, that is M1, and this M1 would be across this split. So your data would be transferred over the network. M2, your data would be transferred over the network, but that will be some small bits of the data and some data over here. And this is how your split comes in picture rather than blocks. So number of mappers equivalent to a number of splits, and split is a logical division of the data. So that might be the case that this whole thing might have crossed this whole block. So in that case, there will be no mapper for this block, and that this whole data would be transferred to the network to this node where this block is processing the data. Put slash n is nothing but a new line ASCII code. So slash n is nothing but the new line ASCII code. So when I'm saying my record is a line, if you remember in this example, I was saying my record is a line, so I'm reading line by line. So when I'm reading line by line, I have to read the whole line to make your mapper function run. So that was slash n I'm talking about. Slash n is nothing but a new line character or segregator. So this is invisible over here, but practically if you look at the zeros and 0 and 1, there's something called slash n over here, which is not visible to you. So does the input split also make sense to everyone? How the input splits comes in picture, and how your smaller data transfer of the network, and how they would divide your data logically to make your mappers and reducer work. And now the mapper has all the data intended for it. Although the data might be logically divided across the nodes, but the map reduce or the reader takes care of it and transfer the logical division of your data to the mapper. And that's the reason number of splits is equivalent to number of mappers, not the number of blocks is equivalent to your mappers. It's always the number of splits equivalent to a mapper. Okay. So now what mapper would be doing up? Mapper would be just, this line would be transferred to a mapper. Mapper will just create keys and values, that is a word and comma one, comma one, comma one, that will reach your reducer. Reducer will produce an output that is the sum of the words. So this is the MapReduce code. We'll talk about this MapReduce code in the next class. Today it will be too heavy for you to digest this part also. But I'll tell you how to run it and how to use it. And I'll just quickly talk you about what are different things in the code. Uh, for the people other than Sally, don't worry about the complexity of Java code. Promise me, I have implemented a lot of big projects in Hadoop and big data related world, and I rarely write a single Java line of code. Everything can be done in high part and the big part. But if you understand the concept, how the mapper is working, how the reducer is working, what I've explained right now in the Excel sheet, that will make you understand the high and big part very, very easily, and that will make you understand everything what is happening at the backend very easily, and you'll be able to optimize your codes. So don't worry about the complexity of this code again, but I'll request you to run this once so that you get a good feeling that you can run the MapReduce code also. But don't worry about the complexities of Java lines and Java things. Uh, I'll explain this thing. What happens? What is written on the code part for your benefit, because if you have attended the Hadoop session later on, no one will be there to explain you what is in the Java code. So just try to get that thing, but don't worry about the complexities of the thing. So for Sally, if you want to look at the deeper sides of the MapReduce things, I can have a separate session with you and can explain you, because in this class you are the only person who has a good Java knowledge. So I can explain you other complexities of the MapReduce part in deeper. If you require, I can have a separate session with you for half an hour, 1 hour, and explain you in that part. I'll not be going into the deeper sides of the MapReduce in this class because people don't use that part also, and for non-Java background, it does not make sense to. So, but if you want, I can have a separate class with you. So, on the MapReduce code, as I was keep on saying, there's something called mapper, there's something called reducer, and there's something called configuration. Yeah, definitely. There's a lot of code which I've shared in the code folder. In the next class, I'll be talking about the advanced MapReduce part. That will be for everyone. So you can just have a look on the advanced codes also, which I'll be discussing in the next class. So I'll be discussing all the concept, all the advanced MapReduce concept, because you have to be aware of the concept. But if you people are not comfortable, I'll not be discussing in detail the Java code. But understand the concept. I want you to understand the concept. I'll be using the same concept in the hive and the pig part. So understand the concept part. If you don't understand Java code, does not matter to me, because you will not be using it. So as I was saying, there's something called mapper, there's something called reducer, and there's some configuration. What we do, how to configure this whole map and reduce word, which is done, which is used by your job tracker to trigger your task trackers. So there's something called map highlighted on my screen. So this is the mapper which I've written up, which is doing that part. In the next class, we'll look into detail what is doing over there. There's a reducer code, which is doing the reducing, or which is doing the sum of your values. Mapper was emitting your word and 1111. Reducer is doing the sum of the values. And the configuration part, which I am saying what is my mapper, what is my reducer, and similar configurations, and where from read the data, where to output the data. So these are the three things which I was keep on talking till now. The configuration part, which is taken by your job tracker, taken care by job tracker, the mapper part, the mapper logic, the reducer logic, and when we run it, if the data is 1 GB, if the data is 1 terabyte, if the data is 1 petabyte, if the data is hexabytes, code will remain same. Your manager will never ask you to optimize the code. Same 8 lines, 10 lines of the code will run. All you have to do is keep on adding the data nodes to make it run faster. So again, we'll do the same thing. We'll use Eclipse. So this code is there. I'll explain what is written in the code in the next class. I don't want to. So this is a class which have the configurations. Where is my input file, output file, mapper, and reducer. And this is a class where I'm outputting the word and the count as one, the mapper class. And this is a class where I'm doing the sum of the values. And in everywhere I have written down the hint how to run this program. So you can just always copy it and run it. So let's try to run it and let's try to see how the MapReduce runs up. In the next class, I'll go in the deeper side of this thing. So again, the same thing, Hadoop, jar name, the jar which I've created, how to create the jar, file, export, give runnable jar, next, give this, now I have to create a word count jar, so I have to select the word count from the drop down. So I'll select the word count and where I have to export the jar, package it, finish it, and use WinSCP to drag and drop it over there to my Unix word. Once the jar is available, Hadoop jar name, the class file name. So for you people, you don't have to give the class file name because you are not creating it from heaven, and the input file which I want to use, and the output directory. So now let's look at some input file in the HDFS word on which I want to do a word count, and we'll use this output directory. So the output directory would be there. So first what I'll do is I'll remove this output directory. Hadoop fs minus rm minus r. And now let's look if there are some files lying at this directory or something lying at this directory. Otherwise, I'll give some other directory. Uh, so there are a lot of files. Let's give only one file. Otherwise, the MapReduce code will take time because this is a small node. Okay. So I'm just giving one file rather than the whole directory, but practically when you are running a MapReduce code, you will be giving directory as an input. But here, just for running it fast, I'm giving one file and a small file so that that runs in 2-3 minutes. So now look at the screen, what is happening, and keep on reading the logs which are emitted on the screen. See, number of splits. My file was small, number of splits is 1. So number of mappers created is, number of mappers would be created 1, would be
Yes. One.
1. Yes. Now you can see it has created the job ID. I've got a job ID. I can browse the job also. So I'll browse it. So over here, if I look at, see, number of mappers would be visible over here also. So if I go to, okay, still it's accepted state only. It's not running. So once it will change to running, I will be able to see the number of mappers. So it has gone to the queue. If you remember the job tracker node, now it's added to the queue. Now job tracker has added to the queue. Now job tracker will slowly and slowly pick the jobs from the queue and assign those, create the task and assign those to the task trackers. So now it has been assigned. Now the job is running. It's in a running mode. So now if I refresh the screen, so now it's running and now I'll be able to see the things. So it's coming up, it's going little slow. And that's now the slowness is because of the overhead of the system. The job tracker, it does all those things, task tracker is doing all those things and all those things. So this is the reason if I remember, I told you have to precisely choose when you have to move to the Hadoop word. If your data is small, this overhead sometimes is more than your data size. So if your data size is good enough for Hadoop word, then only move to the Hadoop word. Otherwise, this overhead would kill you. If you have data of say 1 GB or 2 GB kind of thing, this overhead would kill you. So if you have data related to what we call big data based on the complexity of the algorithm, then only move to the Hadoop one. Otherwise, this overhead of creating all these things would kill you. So you can see over here on not on the hot environment website, Puneet, on the Hue UI. So see number of efforts ran one, number of reducers ran one. So I have not refreshed it. It's saying it has ran it. So over here now you can see everything is done. Your number of bytes read and all those things, the statistics are printed up. Now let's look at the output directory if something is created. So on the Hue UI, let's go to the output directory which I have defined in the program. So if you remember in the program, I have given the output directory as user Hue DP output. So let's look at this directory. User Hue DP design Pathshala output and see one file because number of reducer was one over there. Number of reducers created was one. If you can see over here, uh, somewhere it would be number of reducers. Number of reducers. Somewhere it would be. I hope if you can see, do let me know. Somewhere it would be, or in the on this screen also you can see number of reducers was one. Number of reducers one. So that's the reason only one file is created over here. And if I open this file, all the different words and their counts. Any questions?
Would you recommend that we run this before the next class? Try to do some of the
Yes.
examples?
Yeah. Okay.
Okay.
So I'll come to that part in a minute.
Okay.
Any other questions on this thing? Okay. So one thing you can see, this data is sorted on the keys, that is the words. And this happens with the beauty of again sort and shuffle phase. As I was saying, sort and shuffle phase, the name signifies. So that phase not only shuffles your data to the intended buckets, that phase also sorts your data on the key. So in this case, there was only one reducer. So all your sorted keys reaches your reducer, and when the reducer ran, the keys were sorted only, and the reducer keep on the output from the reducer is sorted only. So your sort and shuffle phase not only shuffles the data to the intended research, that also sorts your data based on your key. And how that is used, how that is helpful, we'll talk later on. But the sort and shuffle phase does one more task, that is sorting your data. Okay, so if no questions from anyone, I'll tell you what you can try over your daytime or over your before your next class. Try to install all these software which I was telling you. And download this putty.exe VMs, OVA files, exe files, and start up your Hadoop VM. Download the Eclipse, download your code, try to import your code into Eclipse, try to export your jar or try to run it from Maven, and try to move this jar to your Hadoop world and try to just run your first MapReduce code that is lying over here. So the line is show the line is sorry. So the file is wordcount.java. So in this file, at the bottom of the file, there's a command how to run it. I'll copy it also and send it to you if you want it. So I've sent it to you people also, and you can just try to run this word count program. And for this word count program, you have to have some data in your SDFS as a file system, not into Unix. SDFS as a file system. So ensure you put some file into SDFS, and how you can put your some file into SDFS, Hadoop FS minus put, or you can use the Hue UI and try to run it. I am sure you will be facing a number of difficulties, but don't worry, we'll discuss that thing in the next class. Anything else? Anyone want to discuss? Talk about? So does it make sense? I want to listen. Other than Sally, I want to listen from others. Was it making sense? Are you able to get it? Because Sally was able to repeat everything what I was talking about. But Padmani, Puneet, Raja,
Yeah, yeah, I am fine, Miraj.
getting it? Okay, so just
Yeah,
try to run your first MapReduce code. Don't worry about the Java code complexity. Just try to create a jar. Okay, and for one more thing. So if you are not able to create a jar again, don't worry. Just go into this code part, MapReduce, and this is a jar. So you can directly use this jar if you are not able to create it. This jar has everything. All the logic implemented in it. You can directly use this jar. So you can just drag out this jar to your Hadoop cluster, and you can use this jar if you don't want to go to the Eclipse complexity, then you don't want to create your jar yourself. So you can use this already created jar. So again, this is lying in the same code folder. So WinSCP is nothing but a FTP protocol by which you can transfer the files from your Windows machine to your Unix machine on which your Hadoop is running up. Okay, so anything else before we wind up? Sure, thank you. Thanks a lot to everyone. Have a nice day, and let's meet tomorrow at the same time. If you have any questions, we'll discuss in the next class then. Thanks, everyone. Bye bye. Have a nice day.